Hello friends, this video is on the topic Fourier series. Starting from the beginning, if I talk about Fourier series, most of the single valued functions which occur in applied mathematics can be expressed in the form a0 by 2 plus a1 cos of x plus a2 cos of 2x plus so on plus b1 sin of x plus b2 sin of 2x plus so on within a desired range. Of values of the variables. Such a series is known as the Fourier series. Starting from the Euler's formula, suppose f of x be any function and we want to express the Fourier series of that function within some interval. If I start with the Fourier series for the function fx, the function is fx, in the interval alpha to alpha plus 2l is given by. How we can write the Fourier series of this function? Within the interval in the general form, this is equal to f of x is equal to a0 by 2 plus summation n varies from 1 to infinity an cos of n pi x by l plus summation n varies from 1 to infinity bn sin of n pi x by l, where a0 is given by 1 by l, range of interval is 0 to alpha plus 2l. So to get the value of a0, do integrate f of x within the range alpha to alpha plus 2l. This will give you the value of a0. And how you will get the value of an? An is equal to 1 by l. Range of integration is from alpha to alpha plus 2l f of x. Now see what with a of n, if you will look at this term is your cos of n pi x by l. Do multiply f of x with the cos of n pi x by l and integrate the same between the range alpha to alpha plus 2l and divide it by l. This will give you the value of an. Similarly, to get the value of bn, what I will do, multiply f of x with, what is with bn? Sin of n pi x by l. Multiply this by sin of n pi x by l and integrate the same between the range alpha to alpha plus 2L and divide it by 1 by L. This will give you the value of Bn. Once you got the value of A0, An and Bn, substitute the value of A0, An and Bn in the equation number 1. This will give you the Fourier series for the function f of x. Fine. These values A0, An and Bn, these are called your Euler's formulas. Euler's formulas. From the same we can generalize the different cases. If I talk about case number 1, suppose the value of, if the value of L is, if L is equal to pi. L is equal to pi, what will happen to the Fourier series? F of x will be your A0 by, it will be our A0 by 2 plus summation n varies from 1 to infinity. Look at your Fourier series for the general form. When you will replace L by pi, what will happen? L and L will cancel out. We will be left with what? Cos of nx. Plus, similarly in the second part, if we substitute or replace L by pi, pi and pi will cancel out. We will be left with sine of nx. Fine. Now this is the Fourier series. If our fx, if fx is in the interval, now interval is alpha 2. This is alpha 2, alpha plus 2 pi. Now, what will be the changes in the Euler's formula? Your changes in the Euler's formula will remain same. Where what you will get? Where A0 will be defined by, now on replacing L by pi, you will get A0 as 1 by pi. Range is here. Now ranges are alpha to, range is from alpha to alpha plus 2 pi fx dx. An is 1 by pi alpha to alpha plus 2 pi f of x cos of nx dx, and Bn is our 1 by pi alpha to alpha plus 2 pi f of x sine of nx dx. This will give me the value of Bn. Once we got the value of A0, An and Bn, we will substitute. That will give me the Fourier series for the function fx within the interval alpha to alpha plus 2 pi. Similarly, if we take L or alpha as minus L, you know what will happen to the function? F of x will become in the interval, when you will replace L by alpha by minus L, it will be defined in the interval L2, L minus L plus 2L, that this will give you L. So what will be your Fourier series? Fourier series will remain same. It will be A0 by 2 plus summation n varies from 1 to infinity An cos of n pi x by L plus summation n varies from 1 to infinity Bn sine of n pi x by L, where formula will remain same. A0, there is change in range of integration only. Now you need to integrate from minus L to L f of x dx. An is 1 by L from minus L to L f of x cos of n pi x by L dx. And what will be our Bn? Bn is 1 by L minus L to L f of x. It will be our f of x sine of n pi x by L dx. Fine. Similarly, we can generate another cases by giving values to alpha and by assuming different values of L. But do remember, as a note, in the expansion of, for the expansion of f of x within the interval alpha to alpha plus 2L, if somebody asks you what is the standard length of interval, length of interval in this case, length of interval always I will take it as 2L. Means while solving the problem, if you have given some interval of some length, I will compare that length with 2L to get the value of L. Fine. With this, we will solve few problems that we will discuss in the next video. I hope the content is clear to you all. It's simply the introduction of the Fourier series. Thank you.